Hello students, welcome. Today Form 2, we are starting chapter 2, that's chemistry of chemical families, pattern and properties. So we are starting our lesson 1 by introducing chemical families. So back in chapter 1, we have learned something called the periodic table. And we said elements in the periodic table are classified into groups and periods. And we were using according to the number of valence electrons and the number of occupied energy levels respectively. That means if we have an element called magnesium, we have to know the atomic number of that magnesium, which is 12. Then we write the electronic configuration for that magnesium, which is 282. So for us to know the group to which this element, that's magnesium, belongs in the periodic table, we have to look the valence electron. That means the number of valence electron in its outermost energy level, which is 2. So that means this element called magnesium belongs to group 2 in the periodic table. And we have to look the number of occupied energy level. The number of occupied energy level in our case here is 3. That means this element, magnesium, is period 3 in the periodic table. Okay, we are told elements in the same group are said to belong to the same chemical family, hence have similar physical and chemical properties. So in this chapter, 4 of these chemical families are considered in details. The 4 families include, the first family is called alkali metals, second family we have alkaline earth metal, third family we have halogens, then the fourth we have the noble gases. So let us start with the alkali metals. So what are alkali metals? So we said these are group 1 elements of the periodic table. So during the exam you can be told what are alkali metals. So the answer is these are group 1 elements of the periodic table. So next you have to know members of alkali metals. Members of alkali metals include lithium, sodium, potassium, rubidium, calcium, and also francium. So during the exam, you will be told about from lithium, sodium, and potassium, state 3 other members of alkali metals. Remember, we said the periodic table, we have 8 groups. We have 8 groups and also 7 periods. So 7 periods, group 1, when we talk about group 1, that means the first element there is hydrogen. But hydrogen is non-metal, it's not a member of alkali. So the first member of alkali will be lithium, which is in period 2, because this is period 1. So that means period 3, which is an alkali, will be that side of sodium, and we are having period 4 to be that of potassium. Remember, in the first 20 elements in the periodic table, they reach up to only the 4th period. But apart from the 4th period, we have the 5th period, the 6th, and also the 7th period. So that means apart from lithium, sodium, and potassium, we have rubidium, we have calcium, and we also have francium. Okay, next, we are told the electron arrangement or electron configuration of the first 3 alkali metal as follows. So lithium is number 3, so electronic configuration will be 2,1. That means the atomic number of lithium is 3. The atomic number of sodium is 11, so electronic arrangement will be 281. Potassium will be 2881. So each alkali metal atom has 1 electron in the outermost energy level, therefore they are monovalent. So we know these are metals and its outermost energy level is having only 1 electron. So for them to undergo ion formation or to become stable, they will lose 1 electron rather than gaining 7. That means the valency of this alkali metal, all of them, is 1. That's why we are saying they are monovalent. That means they're having a valence of 1. So we are told down the group there is an increase in the number of occupied energy levels. That's very correct, because lithium we have 2 occupied energy levels, sodium we have 3 occupied energy levels, and also that of potassium we have 4 occupied energy levels. And the reason why they are having an increase in the number of occupied energy levels is that due to the increase in the number of atomic number. That is due to the increase in the atomic number as you move down the group. Okay, from there, during the exam, you can be told what do alkali metals have in common. So we are saying now all alkali metals have 1 electron in their outermost energy level. That's what they have in common. So next, we are going to have gradation in the size of atom and ion of alkali metal. So what is atomic radius? Atomic radius is the distance between the center of the nucleus and the outermost energy level occupied by electron or electrons. So during the exam, you can be told define atomic radius. So we said atomic radius is the distance between the center of the nucleus and the outermost energy level occupied by electron or electrons. Atomic radius is measured in nanometer, that is in m. Okay, next we are having the atomic radii and the ionic radii of alkali metals increases down the group. So we are having atomic radius. During the exam you can be told explain the trend in the atomic radii and ionic radii of alkali metal. So this is the trend. The trend is that the atomic radii and ionic radii of alkali metals increases down the group. Reason? This is due to the increase in the number of occupied energy levels. Remember, we have seen that earlier on that we said down the group there is an increase in the number of occupied energy levels. As you see here, lithium, we have 2 occupied energy level, we have sodium 3 occupied energy level, we have potassium 4 occupied energy levels. Due to this increase in the number of occupied energy level as you move down the group leads to an increase in the atomic radii and the ionic radii of alkali metals. So next, to compare now, during the exam you can be told compare the atomic radii and the ionic radii of alkali metals. So we are saying the atomic radii is bigger than the ionic radii of alkali metals. Or you can say the ionic radii or the ionic radius is smaller than the atomic radius of alkali metals. Reason? This is because alkali metals form ion. They form ion by losing the single electron from their outermost energy level. Hence, the resulting ion has one occupied energy level less than the corresponding atom. That is why the atomic radii or the atomic radius is bigger than the ionic radii or radius of alkali metal. If we show that one using maybe sodium atom is having 11 electrons with electronic configuration of 281. So when you're having sodium ion, that means when this sodium loses 1 electron, we are going to have or to remain with 10 electrons with electronic configuration of 2,8. So the number of occupied energy level here are 3, but when they lose that 1 electron from the outermost energy level, they are going to have 2 occupied energy levels. That means sodium atoms have more occupied energy level than the ion of sodium. That means sodium will be having more, the atomic radius will be bigger compared to that of the ion of sodium. That's why we are saying the atomic radius is bigger than the ionic radius of alkali metals. Reason? This is because alkali metals form ion by losing the single electron from the outermost energy level. Hence, the resulting ion has 1 occupied energy level less than the corresponding atom, which makes now the atomic radius to be bigger compared to that of alkali metal. Even if we show that one using the atomic and the ionic structure of sodium, the atomic structure of sodium will look like this. Remember, it is having 11 electrons with 3 occupied energy levels. So this is how it is going to look like. So this is the atomic structure for that sodium. Then the atomic radius means, atomic radius we say is the distance between the center of the nucleus and the outermost energy level occupied by electron or electrons. So this is the atomic radius. So let's check the atomic radii, the ionic radii of sodium ion. So it will be having 2 occupied energy levels only, with the first having 2 electrons, then the second having 8 electrons. So like this. So if we check the ionic radii, in our case here, the ionic radii will be from the distance between the center of the nucleus and the last energy level. So if we check here this radius and this radius, that means this radius is bigger than this. This is atomic radius and this is ionic radius. So here we are saying the atomic radii or the atomic radius is bigger than the ionic radius of alkali metals. Reason? This is because alkali metals form ion by losing the single electron from the outermost energy level. Hence, the resulting ion has 1 occupied energy level less than the corresponding atom. Or in short, if you are told compare the atomic and the ionic radii of alkali metals, full stop, give a reason. You say the atomic radii is bigger than the ionic radii of alkali metal, or the ionic radii is smaller than the atomic radii of alkali metals. Reason, this is due to the loss of one electron from the outermost energy level. That's the answer. We are going to stop there. Thank you.